We continue our lecture on functions with some sample exercises. Why is f not a function from the reals to the reals? Part A. Let f of x equal 1 over x. The expression 1 over x is meaningless for x equals 0, which is one of the elements in the domain. Thus, the rule is no rule at all. In other words, f of 0 is not defined. F of x equals the square root of x. The function f of x does not map values to real numbers when x is less than 0. In other words, when x is less than 0, f of x is undefined. F of n is equal, f of x is equal to plus or minus the square root of x squared plus 1. The rule for f is ambiguous. We must have f of x defined uniquely, but here there are two values associated with every x, the positive square root and the negative square root of the quantity x squared plus 1. 7. Find the domain and range of these functions. The function that assigns to each pair of positive integers the maximum of these two integers. The domain is the positive integers, is the Cartesian product of the integers crossed the integers, the positive integers, and the range is a single positive integer. The function that assigns to each positive integer the number of digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that do not appear as decimal digits of the integer. Well, we have the positive integers as the domain, and our range is the natural numbers from between 0 and 9. The function that assigns to a bit string the number of times the block 1, 1 appears. Well, here we have some an expression from regular expressions, which you can learn about if you study automata theory or if you study translator design or compiler deal. What this means is it means 0 or 1, and the star exponent means 0 or more times. So our range is the natural numbers. The function that assigns to a bit string the numerical position of the first one in the string and assigns a value to 0 to a bit string containing all zeros. Again, we can have all bit strings, and the range is the natural numbers. Determine whether the function f from the integers to the integers is onto if f of mn is equal to m plus n. Yes, given any integer n, we have f of 0n equal n, so the function is onto. F of mn equal m squared plus n squared. No, clearly the range contains no negative integers, so the function is not onto. F of mn equals m. Yes, given any integer, we have f of m25 equal m, so the function is onto. We could have used any constant in place of 25 in this argument. F of mn is the absolute value, or the magnitude of n. No, clearly the range contains no negative integers, so the function is not onto. F of mn is the difference of m minus n. Yes, given any integer m, we have f of m0, so m equal m, so the function is onto. Determine whether each of these functions is a bijection from the reals to the reals. Solution. If we can find an inverse, the function is a bijection. Otherwise, we must explain why the function is not one-to-one or not onto. F of x equal 2x plus 1. Bijection, yes. One way to determine whether a function is a bijection is to try to construct the inverse. Solve y equal 2x plus 1 for x, obtaining g of y is equal to y minus 1 over 2. Alternatively, we can argue directly to show that the function is one-to-one, not that if 2x plus 1 equal 2x prime plus 1, then x equal x prime. To show that the function is onto, not that 2 times y, the quantity y minus 1 over 2 plus 1 is equal to y, so every number is in the range. F of x equal x squared plus 1. No, it's not one-to-one because f of 1 is equal to f of minus 1 is equal to 2. not onto, since f of x must be greater than or equal to 1. F of x equal x cubed, yes. This is a function. This function is a bijection since it has an inverse function f of y equal the cube root of y, obtained by solving y equal x cubed for x. F of x equal x squared plus 1 over the quantity x squared plus 2. No, not do 1 to 1, because f of 1 is equal to f of minus 1 is equal to 2/3. Not onto, because the range is the set y is an element of R where y is between 0.5 and 1. And that concludes our lecture.